Good morning, my dear student. Hope you all are fine after the attack of super cyclone in our district and the district that is South Chobis Pargona and Kolkata and other district. So after this attack of the super cyclone, we are again come into the platform of education. So student, I am Dr. Biswajit Gayan from the Department of Chemistry, Dr. Sudhit Chandrasud Degree Engineering College, Dum Dum. Dear student, today I discuss about the pi molecular orbital diagram or pi MOs. You have already have some ideas or the concepts about the MOs, and that's basically sigma MOs. And also there was pi MOs, but here this pi MOs diagram mainly concentrate on organic molecule. Here pi MOs. So pi, we know that the pi orbital. So obviously the pi orbital are involved in the formation of MOs. So where will I find pi orbital in organic molecule? The answer is very simple. We will find pi orbital in the organic molecule where double bond is present. So simply if we consider butadiene, then we have seen that there are four pure pi orbital, four pure p orbital. Now one in one in carbon number 1, sorry for uh, my delay due to the selection of the some highlighter. Here the carbon number 1, this is carbon number 2, 3 and 4, and each orbital, sorry, each carbon have its own p orbital. So now this between 1 and 2 there is a 2 pi orbital, so it can overlap, side on overlap, and can form a bond, that is pi bond, in addition to the sigma bond. Now in 3 and 4 there are also again 2 pi, sorry, p or p orbital, and they can overlap and form a pi bond. Now if we consider in the free state, then in between 2 and 3 there are also pi orbital. if we don't consider the presence of the bond in C1 and C2 or C3 and C4, then there may be a chances of the formation of the bond between C2 and C3. So if I go for the resonance and resonating like structure, we can draw the double bond in between C2 and C3. Is this clear, student? So this bond, that is C1 C2 C3 C4, is not fixed, so there will be chances of the presence of the bond in between 2 and 3 also present. That is, I am saying about the pi bond. Now we are discussing about the pi MOs. So obviously we are not considering the sigma bonding formation orbital, we only considering the pi orbital which form pi bonding. So from the structure it is very clear that there are 4 pi orbital. Now sorry student, so here these are the 4 pi orbital and all are in the bonding situation. So and on the right hand side you are saying that the probability of the psi square, that is probability density. And now if I think there is a pi 1, and if you think about the pi 2, and from the picture you are saying that there is a node in between C2 and C3. So with increasing the node, then the energy of the MO will be increases. So here pi 1 and pi 2, so 4 pure p orbital take part in the bonding formation, so obviously there will be a formation of 4 MO. Now pi 1 and pi 2 are bonding orbital, but after that, that is pi 3 star, and from the picture you are seeing that there are 2 node. So here this is an anti-bonding orbital and its energy is high. And last one, that is pi 4 star, there is 3 node and its energy is the maximum. So in case of the butadiene there are the 4 pi MO, and among these 4 pi MO, 2 pi MOs are bonding state and 2 are in the anti-bonding state. So these are the picture of the 1,3-butadiene and its molecular orbital diagram. Here from this data it is very clear that normal distance between a double bond is 1.34 Armstrong, and for single bond it is 1.54 Armstrong. Now from this picture of 1,3-butadiene, we are saying that the bond between C2 and C3 is appearing as a sigma bond, so it bond length should be 1.54, but no, there is not this data is not satisfying the real structure, but it is in between the single bond and double bond, that is its distance is 1.48 Armstrong. So this data suggests that there will be a resonance, suggests that there will be a overlapping of the pi orbital between C2 and C3. So as the pi overlapping takes place, that's why the bond distance decreases. So it is not perfectly sigma single bond, but it is a somewhat double bond character present in C2 and C3. So here is the difference between sigma bond and the pi molecular orbital. So in case of the sigma molecular orbital, it form head-on overlap of the atomic orbital along the internuclear axis. You have already known about this. And phi molecular orbital are formed on the side-on overlap following a internuclear axis. So when a head-on overlap take place, so then the overlap region is maximum, but in case of the phi molecular orbital, the overlap region is the minimum, although not so much high. So if I think about the collision between the two cars and head-on collision, then obviously there is a maximum damage. But if the collision take place between the two cars of the side on accident, that is, I want to say that is just one car touch it side of another car, then obviously the fatality and the destruction will be not same as like head-on overlap. So similarly here in the chemistry or the formation of the molecular orbital, as the sigma bonding orbital takes place in head overlap, so it's contribute more, or actually overlapping region is the maximum, and here in another case the overlapping region is the minimum. So as a result, the electron cloud is symmetric along the internuclear axis, and electron cloud is not symmetric along the internuclear axis for the pi orbital. And as the head-on overlap is the maximum, so obviously it lead to the formation of the strong bond in case of the sigma bond, but in case of the pi orbital, as it is a side-on overlap, so here the pi bond are not so much strong. Now we are entering another case, that is the pi MOs of benzene. So benzene is somewhat different than 1,3-butadiene, because here is the closed structure of the ring, and here in each carbon atom there is a one p or p orbital, and that are all or undergo pi overlap and from 3 pi orbital pi bond basically. So here it is very interesting thing that as it is a cyclic and all have a pi orbital, so there is a chances of formation of the double bond each of the carbon. So suppose if I think that there is a formation of the C of pi bond among the C1 and C2, yes, there is a pi bond, and C3 and C4 there is another pi bond, but there is a completely same chances of the formation of the pi bond between C2 and C3, because here in this case all the carbon atom in the benzene ring are equivalent. So here the all the bond distance between the two carbon are equivalent. So in benzene ring, uh, if you think about the ring, then there is a pi electron density above the ring, and there is another pi orbital electron density and below the benzene ring. So negative charge is located above the ring and below the ring. So these are the pi molecular orbital structure of the benzene ring. For first pi MO, that is pi 1, is all the lobe are in the above of the plane or on the same side, and here there is no node, and this is the first energy level of the benzene. And now in case of the pi 2, there is a two equivalent structure, that is pi 2 and pi 3, and here you will find only one node. So their energy, that is pi 2 and pi 3, though their arrangement of the placement of the orbital are different, but their arrangement, so as there is only one node, so only one node, so their energy are same. So here in this case benzene, there is a two energy level in the same energy. So this type of energy level is called degenerate energy state. Degenerate energy state. Degenerate energy is defined as there will be a number of energy state and their energy are same, but the state are exist individually. So suppose energy state E1, E2, E3, they are all energy are same and they all are equivalent. So this type of energy level is called degenerate energy state. So now again the similar thing happened in the next energy level, that is pi 4 star and pi 5 star. Here we will find that the number of the node is 2, or 2. So here the energy is increases, and these are also again the degenerate energy level. In case of the pi 6 star, there are 3 node and energy is the highest. So now we come to the filling of the electron. So there is the pi 1, pi 2, pi 3, pi star, pi 5 and pi 6. Here pi 1, pi 2 and pi 3 form bonding orbital or contributed to the bonding, but pi 4, pi 5 and pi 6, these are anti-bonding. So this not stabilizes the system but destabilizes the system, but the pi 1, pi 2 and pi 3 stabilizes the system. So there are 6 pi orbitals, so 6 electron. Is this clear? So 6 electron will be occupied in the new MO, and we know that each energy state can accumulate 2 electrons. So pi 1 can hold 2 electron, pi 2 2 electron, and pi 3 2 electrons. So total 6 electrons are taking part in the bonding orbital. So obviously benzene is stable. So if any electron goes to the antibonding orbital, then it will be not so much stable. But in case of the benzene, in case of the 1,3-butadiene, all the pi electron are present in the bonding orbital. So this system are stable. So this is all about the pi orbital of the benzene, that is ring structure. And another we have already discussed about the 1,3 butadiene structure for the linear gas. So this is the end of this class, and in the next class I will discuss about the aromaticity, which is very important part of the organic compound. We will discuss it in our next class. Student, I request you to please go through the pi MOS diagram, and you have to draw this all picture, because if you not draw the picture, then you can't able to understand the matter. And if you not able to create the concept to draw the molecule and understand the problem, then it is very difficult to represent your answer in the final examination. So please try to absorb the thing and make a concept, so that you can very easily understand, and you can very easily represent this type of the thing in the final examination. So I hope that you enjoy this class, and I always request you or advise you, if you have any problem, you come or approach me very freely without any confusion. So have a nice day. Thank you all for your kind participation and your kind attention. Thank you. Thank you very much. Take care. All the students, take care yourself.